So we're going to continue solving these polynomial equations. Today we're talking about the fundamental theorem of algebra. So the theorem says that if we've got a polynomial of degree n that's greater than 0, then our equation is going to have at least one solution in the set of complex numbers. But there's a corollary to that that says if a function is degree n, then the equation will have exactly n solutions. So before we had said that the degree of the function is going to be the maximum amount of solutions or zeros that a function can have. But this theorem says that that's actually going to tell us exactly how many zeros or solutions that it can have. So not all of them are going to be real. That means we're going to go back to having imaginary as an option on our solutions. So if we're wanting to find the solutions for this, first of all, it's asking us how many solutions does it have. So we look at the degree, what's the biggest exponent, and so this is telling us we're going to have 4 solutions. It's actually 4 because our biggest. And so just like we've done previously, if we're trying to find our solutions, the first thing we do is we look for the real solutions. So we graph it in our calculators. So I've already got it plugged in here, and then as well as the other ones that we're going to look at. We're going to graph this first one. And so once again, we're looking for our zeros or the x-intercepts. And so I can see that there are 2 of them there. Let me get my keyboard here so we can look at the table. So I can see that there's going to be 2 real solutions. Hopefully they're both nice numbers. Looking at my table, looking for where the y values are 0. So you got -2 and -1. So they are nice numbers with them. So 4 solutions. So we're going to have calculator zeros. X is -2 and x is -1. Which means we're also going to have 2 imaginary solutions. So just like what we've done previously, from here, we're going to divide out the 2 solutions that we have. Remember, order doesn't matter here. I'll just go ahead and do the -2 first. So grabbing my coefficients, we've got 1x to the 4th, 1x cubed. There's no x squared term, so I put in 0 for that one. 8x and 8. So following an isosceles division, my first step is to bring down my first number and multiply in the corner. So -2 times 1 is -2. We add down to get -1. Multiply, -2 times -1 is a +2. Add down to get 2. Multiply, -2 times +2 is -4. Add down to get 4. Multiply, -2 times 4 is -8. We add down to get 0. So we divided out our first 0. Now we're going to divide out the second. I'll put -1 in my corner. And then I make sure to use the result from the previous division. So I'll grab the 1, -1, 2, and 4. So I bring down my first term and then multiply. -1 times 1 is -1. Add down to get -2. Multiply, -1 times -2 is a +2. Add down to get 4. Multiply, -1 times 4 is -4. Add down to get 0. So each time we do synthetic division, our exponent goes down by 1. So since we started degree 4, after the first division, we're degree 3. So x cubed minus x squared plus 2x plus 4. So dividing by 1, it's going to decrease the exponent one more time. We've got x squared minus 2x plus 4. So that's what we're left with is a quadratic. Now, normally when we solve quadratics, remember we're trying to find the zeros, when this is equal to 0. We factor if we can, but we've already gotten rid of our nice solutions. So we can go ahead and skip to our next option, which is going to be the quadratic formula. So x is -2 plus or minus the square root of b, -2 squared, minus 4 times a, which is 1, times c, which is 4. And that's all over 2a, so 2 times 1. So let's see, we're going to have a +2 plus or minus. So our discriminant, the stuff under the root, -2 squared is going to become 4. We're subtracting 4 times 1 times 4. So that's 16. So really we have 4 minus 16, which is -12. Still all over 2. So we're right having imaginary solutions. We've got a negative under the root. We can now split apart that radical. So we can make it the square root of -1 to get our imaginary term. And then perfect squares inside of 12 is 4. So we can split that apart to square root 4 and square root 3. This is all still divisible by 2. So let's see, where do we go from here? We've got 2 plus or minus. The square root of -1 becomes I, and the square root of 4 becomes 2. We'll have 2I square root of 3. This is all still over 2. Now we can look at actually dividing. So 2 divided by 2 is 1, plus or minus. 2I divided by 2, which is going to be an I, and we still have our square root 3. So there's the 2 imaginary solutions. We include our original 2 solutions of -2 and -1, and that gives us the 4 solutions we know we're supposed to have. All right, so looking at the next one, finding the zeros. So once again, we're in function notation. We need to get the set equal to 0 to start with. So x to the 5th plus x cubed minus 2x squared minus 12x minus 8. We want to know when that's equal to 0. So I see that it's degree 5. So we know there's going to be 5 zeros here. First step is going to be to graph it and see how many real zeros that we have. Oh, so there we go. All right, so we will grab that one. We will grab this one instead. All right, so let's see what do we get here. Okay, so I can see that there's 2 zeros, but there's something important that's happening here. Notice that one of these is tangent while the other one is crossing. So I know that my tangent one is going to be at least degree 2. If your 0 is tangent, it's going to have an even power attached to it. So I know it's at least degree 2 versus the one that's crossing is probably going to be degree 1. So let's see. We've got zeros at -1 and +2 for our calculated zeros. So what that means is I've actually got at least 3 of the zeros. Now technically, either of those could have a higher multiplicity, but we know they're going to have at least those. So we'll start by dividing out those 3 zeros. So we'll do -1 twice. Start with that. Grab the coefficients, 1x to the 5th, 0x to the 4th, 1x cubed, -2x squared, -12x, and -8. We'll bring down the first term, multiply to get -1, down to get -1, multiply to get to +1, add down to get to 2, multiply to get to -2, add down to get to -4, multiply to get +4, add to get -8, multiply to get +8, and add down to get 0. So this should be a degree 4. And we divide again. So I'll use -1 again for that multiplicity. Using the result that I just got, 1, -1, 2, -4, and -8. Bring down by 1, multiply to get -1, add to get -2, multiply to get +2, add to get 4, multiply to get -4, add to get -8, multiply to get +8, add to get 0. That should be degree 3. And then I'll divide by the other 0, which was at 2, using that result there in blue. So 1, -2, 4, 8. Bring down 1, multiply to get 2, add to get to 0, multiply to get to 0, add 4, multiply to 8, add to 0. So now we're in quadratic. So we've got x squared plus 0x plus 4. So when I set that equal to 0, it's really x squared plus 4 is 0. So we can solve this by taking the square roots. Since we don't have an x term, we just have the x squared. So we can subtract the 4, and we can take the square root. Don't forget that important plus or minus sign. So we are getting imaginary solutions because we have the negative under the root. Negative tells us it's imaginary, and then the square root of 4 is going to be 2. So that's become plus or minus 2i, and then we can original 2 that we had of -1, which is the multiplicity of 2, and a +2. And so that's giving us all 5 solutions, plus or minus 2i, 2 solutions for that multiplicity, and then the solution at 2. So we've got 2 more to look at here as we finish off. So looking at number 1, so it's x to the 5th again, so another 5 solutions on this one. Let's check our graph. Don't want that one anymore, I want this one now. So what do we have? All right, so I can see 3 zeros here. So that means we're going to have 3 real solutions and 2 imaginary solutions. So where are we at? -2, +1, and +2. So those are our calculator zeros. On here, calculator zeros at -2, +1, and +2. So just like with the last problem, we're going to divide all 3 of these out. So -2 first, we got 1x to the 5th, 0x to the 4th, -4x cubed, -1x squared, 0x, and then a +4. So bring down the first term, multiply to get -2, add down to get -2, multiply to get to +4, add to get to 0, multiply to get to 0, add to get to -1, multiply to get to 2, add to get to 2, multiply to get to -4, and add to get to 0. All right, next we'll divide out the +1 using the result that we just got. So 1, -2, 0, -1, +2. We'll bring down the first term, and then we multiply to get 1, add to get -1, multiply to get -1, add to get -1, multiply to get to -1, add to get to -2, multiply to get to -2, and add to get to 0. One more division. Dividing out +2 this time using that result. 1, -1, -1, and -2. Bring down the first term and we multiply to get to 2, add to get to 1, multiply to 2, add to 1, multiply to 2, add to 0. So each time we divide, we decrease our exponent by 1. So in purple, we have an x to the 4th. In the blue, we have an x cubed. And what we're left here in orange then is going to be x squared. So I'm essentially now solving a quadratic. X squared plus x plus 1 equals 0. We're going to use quadratic formula. X is -b, 1 plus or minus the square root of b squared, that's 1, minus 4 times a, which is 1, times c, which is 1, all over 2a, so 2 times 1. All right, so our discriminant, the stuff under the root, we've got 1 squared, and that's 1, minus 4 times 1 times 1. So 1 squared minus 4 is going to get me -3 under the root. And so we can pull out the I from the negative, but 3 can't factor any further. We can't factor it. So all of our solutions here, we've got the -2, the +1, the +2, and our other 2 imaginary solutions will be -1 plus or minus I squared 3 all over 2. This is all 5 solutions. And the last one we're going to look at here is number 3. Number 3 is a cubic. So we're going to have 3 solutions. So first things first, I'm going to look at my graph. That one, that one. So we're hoping to see 3 solutions. Now I only see, I think, 2. Let's change our window. Let's make this -5. Oops, wrong one. Minus instead of negative. -5 to +5. Both directions there. We can zoom in a little bit. Okay, so what I notice here is that it looks like it is crossing at x is -3 is actually tangent that x is -2. So if you just looked at the table, you'll just see those two solutions. So if you can't see it very well, what you can do is you can divide out both of those and get the remaining factor. But if we're clever and are focusing and looking at this graph, noticing that it's tangent at -2, that means it's going to have a multiplicity. So I really don't even need to do any extra work here. I can just get my solutions because of that multiplicity. It's going to get me all three that I needed. So if x is -3, and then also x is -2, and that's the one that has the multiplicity of 2. So that's technically all three solutions. Again, if you don't recognize that, you can get the 2 from the table, divide both of those out, and then set your last factor equal to 0 and get your other solution.